And the solution to a linear equation is any ordered pair, x comma y, that makes the equation true. Now, there are a lot of solutions because there's a lot of points that lie on each line, but you'd be looking for one of them. All right, dependent and independent variable, you want to remember that the dependent variable is the y variable. The y variable always depends on what you plug in for x. So if you think about the equation y equals 2x plus 1, the y value depends on what you choose to plug in for the x. So that makes x being independent. You get to choose it. When we're graphing in standard form would be, for example, 2x plus 4y equals 8. Okay, x plus by equals c. The easiest way to graph it is by finding the two intercepts. The y-intercept is where the x, it crosses the y-axis, and the x-intercept where it crosses the x-axis. All you have to do to find those is you have to plug 0 in for the opposite letter. So the y-intercept occurs when it crosses the y-axis, and this occurs when x is 0, because it would be 0 comma something at that point. The x-intercept occurs where it crosses the x-axis, and that is when the other variable y is equal to 0. You can see that in this picture. This would be like 0 comma 2, and this would be 2 comma 0 if we're counting by ones. Slope we saw in your homework. The formal definition in our book says the steepness of a line, but it's also known as the rate of change. And I'm actually going to skip this one. If you really want to write it down, you can, I guess. But slope is the vertical change over the horizontal change, but I don't really like that one. I'd prefer if we just did rise over run, because that's what most of you are familiar with, which is your vertical change over your horizontal change. And then the other formula you have to have memorized is your y2 minus y1 over x2 minus x1. So these are the ones that we'll need memorized, if you don't already have them memorized. It does say where x2, this should say x2 minus x1 can't be 0. You can't get 0 in the denominator. If you do, the slope is undefined. It's said to be undefined. So today we're just graphing some simple equations. They will be mostly in slope-intercept form. A couple will be in standard form. So this is our slope-intercept form, which is our y equals mx plus b. Remember that m stands for the slope. B stands for the y-intercept. When you're graphing these, you always want to start with the y-intercept. And then you'll use your slope to find other points. So when I used to teach Algebra 1, we'd say the b value tells you where to begin. The m value tells you where to move, so moving up and over, up and over, up and over, or down and over, down and over, down and over. Slope, you're going to be using your rise over run to come up with additional points. So the first one we see y equals 2/3 x minus 1. So this is our mx plus b. This is in slope-intercept form. So again, the b value tells me where to begin. I'm going to start on the y-axis at -1. That's my y-intercept. Just put a point there. Then we're going to use the 2/3 to move. So remember, this is rise over run. So we're going to rise up 2, and then we're going to run over 3. So from the y-intercept, I'm going to count up 2 and over 1, 2, 3, and put a point. I'll also do it again, up 2 and over 1, 2, 3, and put a point. Then you'll use a ruler or your best attempt to draw a straight line through those points. Now, let's suppose that my graph paper didn't have enough squares. Remember that you can also count down 2 and backwards 3 to come up with an additional point. You can always do the inverse, which would be negative and negative, to go down and back to come up with more points. Now the next one is not a fraction. So of course we can see the y-intercept is 3, that's easy. But the slope is just -4. So What can I do to make that into a fraction? Yeah. Put it over a 1. Okay. Put it over a positive 1. Not a negative 1, because if we do put a negative, these would cancel out and make it a positive 4x. So when I'm using rise over run, this is telling me to go down 4. You're still going to the right 1 because it's a positive 1. So we will count down 1, 2, 3, 4, and to the right 1. 1, 2, 3, 4, and to the right 1. Use common sense to look at your line. If the line is going down, like if you sat on it, you would be sliding down the hill, that's a negative slope. If the line is going up, it should have a positive slope. So always just kind of use your common sense to double check that you didn't somehow graph it wrong. The last one on the front is in standard form to begin with. The directions do ask us to write each equation in slope-intercept form first. Okay, so for this one, I am going to solve for y first. Okay, on the back we'll look at graphing in standard form, but I'd like to show it both ways. So how would I solve this equation for y? What would I do to both sides? Gail?
Subtract 4x from both sides.
Good. You need to move the 4x over first to get 2y equals negative 4x plus 8. And then lastly, we have to divide by 2. You do want to make sure that you divide every single number by 2. So all 3 terms. And we will get negative 2x plus 4. So to graph that, we're again going to start at our y-intercept, which is 4. We'll use our slope to find additional points. So again, we'll make that slope into a fraction by putting it over 1. We'll count down 2 and over 1. Down 2 and over 1. And connect that with a linear function. You should have arrows on both tips. Make sure that you don't do this. That's wrong. It's not a segment, it is a line. It needs to extend without end in both directions. On the back, we'll review graphing in standard form, which is our ax plus by equals c. So you probably want to drop that down under our formula. Ax plus by equals c. A, B, and C are usually integers, but they can actually be rational numbers according to the keystone. So they could be fractions. Positive or negative whole numbers. So just like we talked about on the front, the y-intercept is the point in which the line crosses or intersects the y-axis. And that occurs when x is 0. So for example, let's say 0, 3 would be my y-intercept. Just giving an example. Then the x-intercept is the point in which the line crosses the x-axis. And that occurs when y is 0. So let's go ahead and say this occurs at 4, 0. If you graph an equation using the intercepts, you're only going to have 2 points. So when you draw your line, it's not as accurate because you're only using 2 points. So like if you tilt your ruler ever so slightly, it might be just kind of off. So it's not as accurate, but it is helpful to graph, quickly. But you would probably want to use some sort of straight edge, like the edge of a paper, a ruler or something to draw a line a little bit straighter since you only have 2 points. So in the back, all of them are in standard form. I don't care how you do it. So even though it says using intercepts, if you would prefer to subtract 2x and divide by 3, I'm fine with that. When you get in Algebra 2, sometimes with the word problems, it's more useful to do intercepts because you'll be counting by 5s on the y-axis and 200s on the x-axis, and that makes it easier. But if you're finding the x-intercept, that again occurs when y equals 0. So all you'll do if you're choosing this method is to plug in 0 4y. So 3 times 0 is just 0, so that just kind of goes away. I'm left with 2x equals 12. Dividing by 2, I get x equals 6. So my x-intercept is 6, 0. The x is 6, the y would be 0. Finding the y-intercept, that occurs when x equals 0. So taking the equation again, but plugging in 0 for x this time, we'll get 2 times 0 is 0. 3y equals 12. We'll divide both sides by 3. We'll get y equals 4. So that would be 0, 4. So we're going to plot the intercepts and then draw a line through the 2 points. So my x-intercept was at 6. My y-intercept was at 4. And then we're going to connect those with a line. Again, you can see, even like as I'm drawing with my line tool, like it could be ever so slightly off because you're drawing it through only 2 points instead of 3. Last one says graph using intercepts. Go ahead and try that one on your own. And then the closure just asks you to transform the following equation from standard form into slope-intercept form. Remember, slope-intercept form is our mx plus b. So what's the first thing we would do to transform that to slope-intercept form? How would I get the y by itself? Come on, Katie. I know it's too easy, but answer. Add 6x on both sides. And then remember to divide each of the terms by 3. So we would get that our slope is 2 and our y-intercept is -4. Alright, the rest of the time is yours to work on the homework. If you didn't finish it